So this is the first test of the solar tracker. So what I'm going to do here is I'm going to run, in a minute, I'm going to run this program on LabVIEW. But before I do that, I'm going to get an LED and use that to simulate the sun, tracking from east to west, then west to east, south to north, and then north to south, just to make sure that the panel moves in all directions. So what I'll do now is I'll just turn the light off and I'll be back in just a second. So it's time to run the program, and what we'll do then is we'll just see what's happening on the program. So we're going to run it here first, and we're just going to have a look here. So these are all your analog voltages. That's what the light dependent resistors are currently detecting. They're all detecting between a maximum of 1.106 volts down to 0.08 volts. So they're all within a close proximity to each other. That's because the light levels are the same, pretty much the same all round. So what I'm going to do now, as the program is running, I'm going to use an LED here to move. It's now moving to the west as expected, and then it will hit the limit and it cannot move any further. So now it's time to move it in the opposite direction, all the way to the east. And it has stopped at the limit switch. So what we'll do now is we'll bring it around to a central position, back around to the west. And we're going to stop it roughly at a central position. So now what we're going to do is we're going to move it vertical and then move it fully to the south position. So the LED is directly above the panel and the panel is facing it. So now it's time to move to the fully south position. That's going to simulate, when the sun's position is thereabouts on the horizon, it's going to be, the panel should be perpendicular to the ground it's on. So what we'll do now is we'll move the panel fully south. It's hit the limit, it'll move no further. So that's it. If we take a look over here at our graph over time, we can see here we have the blue at 2.1 volts, whereas the red, which is the west, and blue being the east, is down at 0.1 of a volt. Now we can see over here I've set the sensitivity to 0.6 of a volt. So that means when the east was 0.6 or over, above the west, we have that much of a difference, and that'll move the panel in that direction. We can see the other results then for, we'll say, your north to south, where your north there, we'll say, took a jump, and that was above your green, which is the south, and you can see that difference from there, 1 volt down to here, 0.1. That's 0.9 of a volt, which is above our set sensitivity level, and that's when it moved in that direction. So we've moved in all directions. I think everything is fairly successful on the indoor test, so I think at this point it's time to take it outside in a couple of days and see how she behaves.